Good morning, everyone. Today we will discuss about problems on mixed strategy problem. Let us see what is mixed strategy problem and how to find the game value and optimum strategies for player A and player B. Let us take this problem. So before explaining this problem, let us see what is mixed strategy problem. So in case of mixed strategy problem, we don't have saddle point. If you not find a saddle point, those problems are known as mixed strategy problem. Let us take this problem. In a game of matching coins with two players, suppose player A wins rupees 1 when there are two heads, wins nothing when there are two tails, and usually lost rupees 1/2 when there is a head and tail. Construct a payoff matrix and determine what is the game value as well as optimum strategy for these two players. So now, this one I called as player A. This is my player A, and this is my player B. Player B. So now let us see how to construct a payoff matrix for player A and player B. So anyhow, he's saying is a coin matching game. A player A, he may get head or he may get tail if you put a coin. Similarly, player B, he may get head or he may get tail if you put a coin for player B. Now let us see this problem. In a game of matching coins with two players, okay, I took player A and player B, and I mentioned head and tail for both player A and player B. Suppose player A wins, see what are the data we are entering. So in the payoff matrix, it should be related to player A. Suppose player A wins rupees 1 when there are two heads. Look here, this head and this head. When there are two heads, the player A wins rupees 1. So I'll write 1 in the payoff matrix. Wins nothing when there are two tails. Two tails, see this is a tail and this is a tail. Wins nothing means 0. Wins nothing when there are two tails for player A. And usually lost 1/2 when there is a head and tail or tail and head. Just look here. This is the head and this is the tail. You will lose 0.5 rupees, 0.5 or 1/2. And similarly, tail and head, you will lose 0.5 rupees. So this is the payoff matrix for the given payoff matrix for the given problem. So after constructing the payoff matrix, now we need to determine the optimum strategies for these two players. Let us see how to find the optimum strategy for these two players. So now, I'll take the difference 1 minus my 1 minus of minus 0.5. So that is 1.5. Similarly, this side in this way 0 minus of minus 0.5. So that is 0.5. Similarly, with respect to vertical, 1 minus of minus 0.5. So that is 1.5. Similarly, in this way, 0 minus of minus 0.5. That is 0.5. 1 minute. I'll make some corrections. So here 1 minus of minus 0.5. That is 1.5. We need to write in the second row. Similarly, this side 0 minus of minus 0.5, that is 0.5, we need to write it in the first row, just we need to alter. Then this side 1 minus of minus 0.5, that is 1.5, so I'll write it here in the second column. And look at the first column, 0 minus of 0.5, that is 0.5, I'll write it in the first column. Now, we need to find the strategies. See, strategy for this player is 0.5 divided by sum of, right, 0.5 divided by sum of 0.5 plus 1.5. So that gives the optimum strategy for this player. So we are getting 0.5 divided by 2. So it is 0.5 divided by 2 is getting a 0.25. This is the optimum strategy. And similarly for this one, 1.5 divided by 1.5 divided by 0.5 plus 1.5. So this is 1.5 divided by 2. 1.5 by 2 is 0.75. 0.75 is the optimum strategy for player A. Now go for player B. For player B is it is 0.5 divided by sum of these two. That is 0.5 plus 1.5. So we are getting 0.5 divided by 2, that is 0.25. This is the optimum strategy for this one. Similarly for this one, the optimum strategy for here it is 1.5 divided by sum of 0.5 and 1.5. 0.5 plus 1.5. So that is 1.5 divided by 2. 1.5 by 2 is 0.75. Now I'll write a statement: optimum strategy for player A and player B. Optimum strategy for player A is player A means row wise 0.25 and 0.75. 0.25 comma 0.75. So now similarly I'll go to optimum strategy for next player B. Let us see for player B. Now I'll take optimum strategy for player B. I will write it as look at the column wise 0.5 comma not 0.5, it is 0.25 comma 0.775. So this is the optimum strategy for player B. So now we calculated a payoff matrix and we calculate optimum strategy for player A and player B. And last one is we need to determine the game value. To find the game value, I will select this matrix, payoff matrix. So now use this formula. So game value is equal to product of PD. PD means principal diagonals. This is a principal 1 and 0 are the principal diagonals minus product of secondary diagonals. Secondary diagonals are minus 0.5 and minus 0.5 divided by sum of PD minus sum of SD. That is a game value. That is a formula you need to remember. So as per this formula, the product of principal diagonals, say 1 into 0 minus product of secondary diagonals minus 0.5 into minus 0.5 divided by sum of principal diagonals 1 plus 0 minus sum of secondary diagonals, that is minus 0.5 plus minus 0.5. So that gives the minus 1.25. This will be the game value for the given problem. So this is belongs to mixed strategy problem. So that's why we need to, because since there is no saddle point, that's why we are calling as mixed strategy problem. To find the game value and optimum strategy for the mixed strategy problem, you need to follow these procedures. So with this, I conclude my today's sessions. Thank you so much.